Yes, hello, my name is William John Johns III, and I'm attending the University of Advancing Technology in Tempe, Arizona. I attend online, and I'm taking a course called MS539 Programming Concepts, and I'm new to computer programming for the most part. My first assignment was to make a GitHub account. I had one already, but I had to update it, and then I had to add a new repository of code in C# from using Visual Studio 2022 Community Edition. And Professor Tony Hinton, very nice competent man, he basically wanted us to make a simulation as our first program. And I'm doing basically an educational sim, not too complicated, but it just uses some of the functionality of Visual Studio 2022, and I have to write some code in it and use the drag and drop Visual Studio aspects of the program as well, just getting familiar with the software and such. So he told us we could do it in anything we wanted, and I'm interested in some quantum physics, in particular space-time, and there's a concept by John Wheeler who postulated or theorized in 1955. He talked about, I looked it up here on OpenAI, ChatGPT 4.5, research preview with a deep research dive. But basically, what he did was he talked about the quantum background. Quantum foam is a concept describing space-time as turbulent and frothy at the smallest scales. And there's different types of quantum gravity theories to describe this foam that he spoke of. There's a standard quantum foam we call Wheeler's model, and there's also loop quantum gravity, spin networks, holographic principle, and what I'm proposing is a quasi-foam quantum state, which kind of incorporates all of it together and also speaks towards information flow and energy flows in the context of the hybrid model. So that was what I wanted to do my educational sim on as I'm exploring that subject matter. What I did basically was I was told we couldn't use any kind of AI for the coding. We need to code ourselves using Visual Studio. I did do some Google searches here and there when I got stuck on how to do some aspects of code, but it wasn't strictly like a large language model search. But we were able to use large language models for content of the sim, whatever we're researching, and for any kind of visuals. So I used OpenAI's ChatGPT 4.5 research deep download. I have a pro edition of the ChatGPT, works out quite well. And I ask questions in multiple different ways until I get the content that I want. It works quite well. And for any kind of image generation, I use ChatGPT 4.0 because that's what makes the good visuals for that. So I got my content to where I want it to look like, and then I entered the content to get the visuals. So that's that aspect of it. So down here you can see that I have a GitHub account, and it's basically I have two programs in repository. One is the Hello World, and then the other one is the new project. So I can look at the new project now. It's Quasi-Foam Quantum State Sim, July 2025, for my class demo MS539 Programming Concepts, July 25501. Theme Quasi-Foam Quantum State Sim, July. And I licensed that in Apache, license 2.0, so anybody's free to use the code and any content that I'm creating. I had another repository from before I was exploring this coding. That was 2018, so it was a little while ago. Yeah, my handle is SurferGuy71, did a lot of surfing throughout the years, so it's kind of reflecting on that. But to make this video, I'm using Loom free software, so it has I can adjust the picture myself anywhere I want, and also do the screen share at the same time. I thought that would be more effective, so I could just kind of walk everyone through it. So basically, when I basically go into Visual Studio 2022, I just click here, that pops up, And so I look at my code, Quasi-Foam Quantum State UAT, and then as instructed, I try to keep the properties and toolboxes to the side here, and basically have the solution explorer on the bottom. So this is my my form design. Basically, I had to put in labels here for some description of the quasi-foam, a unified model process of space-time incorporating elements of standard ruler space foam, loop quantum gravity spin networks with holographic principal surface information layers. And this yields a demonstration of the information flow. Put another label here, toggle below for model building blocks. And then the next 4 labels are actually buttons. The standard ruler space foam, holographic principal surface, loop quantum gravity spin network, and quasi-foam quantum state, which again is a postulate that I'm making. It's not a proven theory, unless like all the mathematics would support that working model. But anyways, so these are some of the images. I set the background of the form to one of the images that I researched and created with the help of OpenAI 4.0 after a 4.5 search. And then basically the other aspects of this program are picture boxes. But I wanted you to see the basic outline of the first slide first, so I set all the visibility to false on all the picture boxes so they don't automatically pop up. And then I did write a little bit of code, and I overcommented as recommended. So basically, under the button, this button event is intended to handle the standard Wheeler space foam concept picture box image. Toggle action can be implemented here to visualize the simulate the Wheeler space foam. Will make image visible by toggling true false. So I said the picture box Wheeler standard space foam visible equals exclamation picture box Wheeler standard space foam visible. So basically, it makes it so when you click on the button, it turns my visibility from false to true. You click it again, it turns from true to false, and so on and so forth. And I did that for all 4 picture box buttons, or 4 buttons that correlate to the picture box. So I can run this program for you just to show you how this plays out. And also, another thing I had to tell you about before I run the program, basically all the images that I created were in UHD PNG files. They're quite large. So when I initially loaded all my files to GitHub, it wouldn't actually let me fully load the the repository because they said the file was too large. So I was kind of in a crisis. So mini crisis actually. So I basically went back to my program and tried to eliminate some code. That didn't go well. So I had so many errors that it got pretty ugly. So I basically just scrapped my first working model. Then what I did was I downloaded some free software from the Windows website, Microsoft Windows website for it's called a program called Tiny PNG. So basically, I took all my images and they were in UHD, pretty big files. I reduced the quality from 100 down to 50%, fed the files into this program, and then you can see like I take an initial file of 1.48, compress it down to 104.9 kilobytes, 93.1% smaller, and only lose half the resolution. For starting with 4K, I figured that's pretty good. So basically, then I went into files, and I went from my images. I made a lot of images I didn't use for the program just because basically I'm exploring exactly what I wanted the image to display in conjunction with my thoughts and ideas of what this would actually look like. So I put all the images here, and then I would feed these images into this PNG program, basically, and it tells me where the output location is going to be. And so basically my output location I decided was going to be basically in my Quantum Foam project. And so basically I made another file that just took the compressed images that you see in my program. See, so basically that's the long and short of that. I could always make another video with a lot more of the interesting files I created, but that's not really the purpose of this video. It's more for how the program works, it runs. So now we go back to the program here. If I hit this again, this is Microsoft Visual Studio 2022 Community Edition. And I had to change just a little, talk through. I had to change, or I had to set the different labels, the color, the size, the spacing, how I want that to look, the bold print. It took us a little while to get that exactly dialed in, then set up the buttons, the same processes. These are all actual picture boxes that were labeled and sized, and then those picture boxes again are all set to false, and then I wrote the code in it to toggle from false to true and back. So now we'll actually run the program. So this is the program here, Quasi-Foam Quantum State, a unified monopositive space-time according elements of standard Wheeler space foam, loop quantum gravity spin networks, and holographic principal surface information layers. This yields and demonstrates information flow as well. And then I wrote here, toggle below for model building blocks. So this what you're seeing here overall is the postulated model that I'm speaking of for space-time being quasi-foam quantum state. You can see the hologram here. You can see the Wheeler bubbles model, virtual bubbles, real, kind of back and forth. And there's also the loop quantum gravity spin network, which is the lattice work and framework. And anyway, so if you so I said toggle below for model building blocks. If you look at the standard Wheeler space foam, you click on that, and this is a simulated model of a Wheeler model, standard quantum foam, virtual particle bubbles, quantum fluctuation, curvature vortex, and you kind of see that aspect in the overall picture. But this is something that's been looked at, again, it was in 1955, but I wanted to expand on what a more in-depth model looked like, incorporating other aspects of physics at the same time into something that may be more useful potentially, who knows. Now you can click on this again and it disappears. Holographic principal surface information. This is talking about how you could have an information on a planar field that could actually code from a 2D to 3D representation, encoded data bits, emergent 3D image file, holographic boundary. You can see how that might look, and again you can click on it again and you can see in the picture you have the holographic information here with this is where the data or information flow, energy flow would go between. Loop quantum gravity spin network, that's looking more at the lattice work here. So if you click on this is a representation of what that lattice work might look like. Again, this is all at a Planck scale. It would be like 10 to the negative 35 meters, or, below the size of an atom. So this is the basics fabric of space-time. So, and then the quasi-foam quantum state again is similar to the picture that you see here, but this is just another working model that I looked at. And this is again the foam, the lattice work. You have a holographic data layer, and information wraps back onto another aspect of the data layer, and it all correlates together. But yeah, so I had some errors working on the program. I forgot some small things. I had the one crisis where the file was too big with all my PNG 4K files or UHD files, and again I took a shot at just reducing the size and changing it from PNG to JPEG. I lost some resolution, but basically GitHub took that collection of files, and so I could actually submit it for a class or keep it in the repository. And it's not too far off from how I had it working for Visual Studio. Worked it up at the highest resolution, just I wasn't able to transfer that in the repository. So basically I made it work. So it's very simple, rudimentary, but this is my, I guess, second to the Hello World project. This is my first legitimate working model from Visual Studio 2022. Again, looking at some physics constructs that I'm interested in. Again, this is a postulate, but these are more the other three are more, I guess, models that have been looked upon in the past. But once again, it's just you can toggle these off, on and off. And then my next project will be a graphical user interface. I don't know if I'm going to work on this project or something similar, probably something similar. And I might leave this for now until I get some feedback on that. But that's the long and short. I really appreciate you guys watching this. Thank you very much. And today's date, I didn't say, was July 14th, 2025. This video started at about 3:25. It's about a 15-minute long video, longer than I thought it would be. This is the first take, and we'll see how it goes. All right, appreciate it very much. Thank you very much. And until next time.